Example number 3. So determine the coordinates of the trig point half y in the fourth quadrant. So in this case, I'm being told that I'm dealing with a trig point. So I definitely know that those points x and y are going to satisfy my equation x squared plus y squared is equal to 1. So the value of x in this case is half, so I can make that substitution automatically. All I need to do now is solve for the value of y. So I bring over that half squared and I get y squared is equal to 1 minus half squared, and half squared is equivalent to 1 over 4. So y squared is equal to 1 minus a quarter, and we get y squared is equal to 3 quarters. Now to solve for my y, I need to take the square root on both sides, which results in the positive and negative root 3 over 2. Now in this case, how do I know which one to choose? Do I choose the positive or the negative? Well, the answer is directly in the question. I'm being told that I'm in the fourth quadrant. So in the fourth quadrant, what do we know about the y value? Well, the fourth quadrant is below the x-axis, which means the value of y must be negative. Therefore, I'm able to assume that I can reject the positive answer and accept the negative one. And my point would be found at half and negative root 3 over 2. So the general rule. You can find the exact coordinates of any trig point if you know the angle of rotation. So your point, which goes through a certain angle of rotation, which we have called theta, will result in an x and y coordinate of cosine theta and sine theta. Now your theta can be in degrees or radians, no big deal. But let's try and explain why the value of x is cosine theta and why the value of y is sine theta. So if we go back to the triangle that was formed in our unit circle, because we were dealing with a unit circle, the radius was 1, which resulted in a hypotenuse of 1. We also know that we had a certain angle of rotation, which we call theta, and that our trig point was found at x and y. So the value of x would be x, and the value of y is y. So if I were to look at this angle and the trig ratios, sine and cosine, I would be able to come up with this ratio. The cosine of theta, which is the adjacent over the hypotenuse, is equivalent to x over 1. And anything divided by 1 results in itself. So that means the cosine of theta is equal to x. Ideally, the same thing would happen with sine, and it does. So sine theta is equal to y divided by 1. And because it's being divided by 1, we can just forget about that, and we can say sine theta is equal to y. So all I did is I substituted the value of x and y in my coordinates with cos of theta and sine of theta. Now what does this do? What benefit could this do for me? Well, this results in what we call the trig circle. And I know it looks really intimidating at first, but it's not that difficult. All you need to really remember here is quadrant 1. And the reason for that is because quadrant 1 is always dealing with those remarkable angles that we were introduced to previously. So the x value I just mentioned to you is the cosine of theta. So the cosine of 30 degrees is root 3 over 2. And the sine of 30 degrees is 1/2. The same can be said for 45 degrees. So the cosine of 45 and the sine of 45 are equivalent in this case. And then the same thing could be done with cosine of 60 and the sine of 60. Now, in addition, this unit circle also has the radian measures for the angle. So any angle that you see in degrees can always be expressed in radians. Now, what I want you to notice is that you don't need to remember this 120, 135, 150 at all. That's not even relevant. What I want you to do from now on is just ask yourself, what is the reference angle? So for 135, what reference angle are you dealing with? In this case, it would be 45. For 150, what would be your reference angle? And it would be 30. For 240, what is your reference angle? And the answer is 60. If you forgot what a reference angle was, well, let me just remind you. The reference angle is the acute angle that is formed with the terminal side and the horizontal axis. So it could be the positive or negative x-axis. And there's another pattern here that emerges. So anytime you have a reference angle of 30 degrees, so 30 or 150 or 210 or 330 as an angle of rotation, what do you get for the angle of your radians? Well, you always get a denominator of 6. So for a reference angle of 30, you get pi over 6. And when you have an angle of rotation of 150, your reference again is 30, so that would be 5 pi over 6. 7 pi over 6 for 30 degrees in quadrant 3. And 30 degrees in quadrant 4 would be 11 pi over 6. So anytime your reference is 30, you have a denominator of 6. If you have a reference of 45, you end up with a denominator of 4. And if you have a reference angle of 60 degrees, you have a denominator of 3. So ideally, if you were to look at all of these values, the x and the y for 30 degrees, you would notice that they have the same numerical value. The only thing that's different is the sign. Some may be negative, some may be positive. So how would you determine the sign? Well, you would ask yourself, am I in the positive y direction or the negative y direction? The positive x or the negative x direction? So, important points that we need to know. If no unit is given, radians is implied. If pi is being used, then radians is implied as well. And whenever you are going to see a point with an angle of rotation, it's a way of describing a trig point. So the point tells you that it's a point, so that P is what is describing that to you. And then this pi over 4, or any value in radians, tells you the angle of rotation. And you can also have it written in terms of degrees. Now what this actually means is that you always use your reference angle to find the coordinates, and then you determine your sign based on which quadrant you are in. So let's just give this a little bit of a test now. So let's go back to our table that we introduced prior, and let's say, okay, well, for 30 degrees, we know that's pi over 6. 45 degrees, that's pi over 4. 60 is pi over 3, and 90 is pi over 2. This is all you need to remember. That's all I want you to remember from now on. Let's test this out with some examples. So what are the exact coordinates of your point with an angle of rotation of pi over 6 and your point with an angle of rotation of 225? So, going back to our unit circle, a rotation of pi over 6 would be equivalent to 30 degrees. So what I can actually say is that my point with an angle of rotation of pi over 6 would be found at the cosine of pi over 6 and the sine of pi over 6. Which is the same thing like saying the root 3 over 2 and half. For 225 degrees, I can make a conversion into radians, or I can just ask myself, what is the reference angle for 225? And I would say, okay, well, how far am I from 180? Well, 45 degrees. So I know I'm dealing with a reference angle of 45 degrees, and I have to be in quadrant 3. So I end up with the cosine of 5 pi over 4 and the sine of 5 pi over 4, and I get negative root 2 over 2 and negative root 2 over 2. Lastly, we get to the next type of question, which is knowing how to figure out the exact value of other types of trig ratios. Now, to do this, what I want you to do is just put down all the information we know. So I know that my point is found at x and y, which is cosine theta and sine of theta. And what is the cosine of theta? Well, it's your adjacent divided by your hypotenuse. So your adjacent in this case would be 4, and your hypotenuse is 5. And for your sine, you would do the exact same thing. Sine is equivalent to opposite over hypotenuse, which is 3 over 5 in this case. So the next step is just draw yourself a triangle and add a theta. And then you can just substitute the values in your triangle. Now that you have this visual, it will be so much easier just to say, okay, well, what is tan? Tan is the opposite over adjacent, or 3 over 4. Now, what is cosecant? Cosecant is the reciprocal of 1 over sine. So I should get 5 over 3, and I do. What about secant? Well, secant again is also the reciprocal. It's the reciprocal of cosine, which means I get 5 over 4. Now you could do this many different ways. You don't even need to draw this triangle. But drawing the triangle will help you if you are more of a visual person.